Hi, everybody. This is Joanne, Science Goddess on Twitter, and I'm here with my co-host, Jeff Schomeyer. We are Read Science, and we are trying a new platform these days, so hopefully everything's crystal clear and wonderful. And we are so excited to have three authors here who put together a really great field guide, the Field Guide to Citizen Science, how you can contribute to scientific research and make a difference. So our the first author listed here is Darlene Cavalier, right?
Correct.
Yes, and then we also have Katherine Hoffman.
Hello.
And Karen Cooper.
Hey.
And what I'm going to do is to find where I wrote, Darlene, your bio. Feel free to interrupt me and say, oh, that's not right anymore. Okay, so Darlene Cavalier is a professor of practice at Arizona State University School for the Future of Innovation in Society. She is the founder of SciStarter, a popular citizen science portal and research platform connecting millions of people to real science that they can do. And that's what we'll talk about today a little bit, right? You are also the founder of Science Cheerleaders, a nonprofit organization comprised of current and former NFL, NBA, and college cheerleaders pursuing STEM careers. And you're a founding member of the Citizen Science Association, an advisor and fellow at National Geographic. And are you still with the EPA's National Advisory Council?
Well, it was disbanded.
I was wondering about that. Okay, so. And anyway, you were recently appointed to the National Academy of Sciences Designing Citizen Science to Support Science Learning Committee. And you are the co-editor of a book that I know I have and I can't find it, The Rightful Place of Science, Citizen Science, the author of The Science of Cheerleader, and co-author of this book. So, and yeah, welcome. Glad you could join us. I've been meaning to have you on.
It's been a long time. I'm so happy for this opportunity. Thank you.
Yes, you're welcome. Yeah.
Katherine Hoffman, I'm told, has an interest in science engagement, or had an interest in science engagement, and still does, and happily had a mentor who urged her to become involved in citizen science somehow, which she did by joining up with SciStarter to do project management, which led to being a managing director of SciStarter. Cool. She's an avid citizen scientist herself, speaking to the public on the subject and contributing to several citizen science projects discussed in the book, and spreading enthusiasm for science wherever she can. Glad to have you here, Katherine.
Thanks for having me.
Hey, all right. And I can introduce Karen. Karen, living in North Carolina, close enough to my sister. I can say hi to my sister. Karen Cooper is an associate professor of forestry and environmental resources, the Chancellor's Faculty Excellence Program on Leadership in Public Science at North Carolina State University. She studies bird ecology and conservation through the use of citizen science. And through citizen science, she says people anywhere at any time can lend a hand in carrying out genuine scientific research. Yay, that's what we're going to talk about. You're an advocate for the practices of citizen science, open science, and science communication, pursuing scholarly inquiry into these areas and bringing them all together to achieve public science. And I saw your name a couple times in the book, involved with some of the apps, but you've also been involved in other ones, Nest Watch, Cam Clicker, Celebrate Urban Birds, and Yard Map. So looking forward to learning about all of these things. Thanks for joining us, Karen.
Okay. Thanks. Yeah. Thank you. I'm super glad to be here.
All right.
Okay.
Jeff.
On the subject of citizen science, which is our subject for today, I particularly like Discover Magazine's review of this book with the title, Get Out, Do Science, Make a Difference. What a fabulous title. This is an enthusiastic description of the joys of doing citizen science, but there's another valuable point to be made. Early in the book, you had the occasion to make the statement, citizen science is serious science. And I'd like to start with an opening statement, if you will. about what that idea means, how it could possibly be true, and how important it is to the idea of citizen science. I'm going to tap Darlene to start.
That's partly because, thank you, and thank you for zeroing in on that point too. Sometimes when people hear the term citizen science, they associate STEM engagement. Oh, we're just trying to teach people something. And for so long, adults in particular have been marginalized when it comes to public engagement and science opportunities. And you can see that most STEM programs are aimed at kids. So we understand why people go there with that mentality. The next, I guess, error in understanding what citizen science is not that it's just like STEM programs for kids, but that it's also not real science. It's activities that you might do for your leisure at home, not really understanding that it's advancing important areas of research across almost every domain in science. I typically refer to Karen's work at this point because she did a lot of work in uncovering really important outcomes that have resulted from citizen science. So tossing the mic to Karen, if I may.
Yeah.
I think, serious science.
Well, I think what underlies that question too is that people have a hard time believing that people who aren't trained as scientists, right? Because training to be a scientist takes years and years of schooling. And so people have this like innate like disbelief that like, wait, someone who hasn't had all that training actually has something valuable to contribute. And they do, because the way citizen science is structured relies on like bringing together a whole bunch of experiences of local knowledge or some types of natural history skills or whatever it is that actually people do possess to advance scientific research. So yeah, like Darlene said, my favorite thing to do is like to talk about and give examples of things that we've discovered that we wouldn't have known if it hadn't have been for citizen science. And one that I think a lot of people are familiar with, just as an example, very iconic in the field of entomology, is like monarch butterflies migrate from the Midwestern US 4,000 miles all the way to Mexico, right? And people kind of take that for granted, like, yeah, we all know about this monarch migration, but that was a mystery for so long. And it wasn't like a scientist that discovered it. It was really hundreds, maybe thousands of school teachers and their students putting little stickers on these butterflies until finally someone saw a marked monarch in Mexico. So anyway, there's a lot of discoveries like that, though, that it just takes, that patterns aren't really revealed until a lot of people are sharing their observations from all over the world.
And that was the 70s, right? So that was a while ago. Yeah.
Right. It's an old practice. It's not new.
Yeah,
So,
at all.
It was while I was in college, Jan, because I remember the mystery revealed, and it seemed an amazing thing. Catherine, go ahead.
Yeah, I was just going to add, I think that it's an approach that achieves science that can't be done any other way. Like Karen was saying, when a single individual scientist can't go and track all of these monarchs. And so really bringing people together to achieve those goals is the way that, we get these big questions done. And so, it's exciting for people who have that expert knowledge and what's going on in their backyard and what they're seeing every day. That's valuable information that, Karen, as the researcher on birds, is not in your backyard seeing what's going on. You're the expert in that area. And so, and that's true expertise in what you know and what you understand.
For a lot of the 20th century, early in the 20th century even, there were a lot of people who had weather stations that they took care of. And I think some of their friends look on them as eccentrics who just like to measure things and perhaps never understood that they were actually part of the National Weather Network that helped track things and ultimately led to building national weather maps and then even the climate models that we use now. So it is, honest to goodness, real science. And I have to say that as a real scientist, I don't poo-poo that. I feel like I can see rather easily how it could fit in. And it was a great idea when people started doing it. It's like, this is what, in the early part of this 21st century, we first started calling crowdsourcing our science, right? Yeah, and we also, fairly recently, we talked to Sarah Parzak about her archaeology from space, where she is using, and other people are using, satellite imagery to filter and look for promising archaeological sites. And she does this with the help of modestly trained citizen scientists who are able to look at these and detect these patterns much more easily than any computer could ever be taught to do.
Right. That's a hugely growing area in citizen science. There's a lot of areas where there's sort of a data deluge. There's so much information, and actually our computers can't process it. Whether it's like, old scanned documents from herbariums or images or, automated telescopes, whatever it might be. And our computers are not as smart as us, right? We can recognize patterns and things. And so, it takes that crowdsource effort.
Now that the Hubble telescope can take deep field cameras that reveals 100,000 galaxies at one time, what to do with all of those and how in the world do you make a map? Well, Intergalaxy Zoo, right, which asks people to do things. And how quickly have people designing these projects, gotten clever at structuring the research so that it can be done with the help of people? That has to start, it seems to me, from pretty much the beginning, but people have some very good ideas about how to do that.
They have good ideas, and they are fortunate to have a lot of tools to help them with that. So it's not as common now where a single researcher needs to go get a grant to develop the whole infrastructure for their project. So you have SciStarter that can help with recruiting and helping to manage the volunteers and with promotions and so forth, and driving some of the research that Karen does. And then you have platforms like you just named one of Zooniverse, Galaxy Zoo being run on Zooniverse, as well as iNaturalist and something called Anecdata and SitSci.org, and these amazing platforms and tools that help people who have good ideas and valid research questions not have to worry so much about reinventing infrastructure, and help people both discover their project and then add data so that they can advance these areas of research.
And barely 25 years ago, we didn't have the internet the way it is today. We didn't have social media to build all these things on. That makes a vast difference too.
And the phone, like to be able to georeference a location, like in terms of data quality and data validation, having people be able to take a photograph with a georeference and have that be what's documented instead of just, their word for it is a big deal. And also being able to have more people then help identify whatever's in that image. So now if I'm someone who doesn't know anything about mushrooms, I can take a picture of a mushroom though, right? And then someone who is an expert can identify it, and we can share our different expertise. I'm in the right place at the right time to get that photo, but someone with the expertise to identify it is somewhere else.
Yeah, and I'm like, when I was a young girl, I mean, my favorite thing to do was to go out in nature. Even though my plan was to become a doctor, like I was always in the boonies of Guam. And I just if I had stuff like this I would have been the most overly enthusiastic person joining every single activity, possible. So I just imagine how wonderful this is for curious kids to just get in there and join and to be a part of real science, or even just get questions answered. What's that bird? What's this?
And curious adults, because what you just described is Catherine is the adult version of what you just described. She even talked about on her wedding day, maybe going up and down the aisle.
Well, you made one other very telling statement in the book too, that not every person who is interested in science wants to become a science professional. And this is a way to express motivation and interest and to make a real difference. It's awfully hard for people. Just look at the voting patterns of people. It's hard for them to believe that they can do anything that makes a difference, I think. But they really can with these projects, right?
Yeah.
Okay.
I was saying, I think that's a huge point, in just that it's an opportunity. If you love science and you love, the environment, or you love astronomy, but you decide to become a journalist, or you work in finance, or you work at a business. And I think it can feel like, okay, I have to kind of give that part of me up, or that's something I can't really, get involved in as much. And, that's not true. And I think citizen science offers an opportunity for people to continue to, explore those passions, and then find, more ways to get involved. So they start with, taking pictures of, a bird that they see, and then all of a sudden they're advocating for conservation policy. And I think that that's kind of the key, is that, if you love science and the environment, great. If you want to be a scientist, great. If you don't, that doesn't mean you have to give up that passion. And, this is a way that we can encourage that to move forward.
It really helps you see your environment more, doesn't it?
And I hear there's a whole class sort of citizen science that isn't even necessarily, it's not necessarily motivated by curiosity so much as just concern for one's environment, right? And for the health and safety of the environment that someone's living in. So sort of monitoring waterways, right? And the health of streams and lakes and rivers and drinking water, and monitoring air quality, and those kinds of things, often initiated by particular communities that might be experiencing harms, is also. So sometimes citizen science is needed because people need access to science, to systems through which they can advocate for change.
Environmental health and human health projects out there now. There's one called Flu Near You. It's so ideal for right now. It's helping to predict flu outbreaks. And there, there's projects that help accelerate research on Alzheimer's. So yes, the motivation for projects is unbelievably diverse. I think we try not to put a value system on the level of engagement as a sign of like, well, that's an important citizen science project, because I mean, just to get in the weeds with this, sometimes projects may be criticized by people in our field if they aren't like community driven. People got together, they came. That's a lot of effort. That's a lot to ask of people who aren't necessarily immediately threatened by their environment. It's a lot just to ask somebody to not watch, instead of reading a book or watching a movie or TV, to go out there and actually engage in these projects. It's a lot of work. And I'm telling you, just to get somebody to commit to volunteering and taking action to things.
But there's a lot of reasons that can draw people in. It doesn't really matter what it is, does it? And then they do that, they get to contribute, and chances are more than not that it's going to spark their interest in knowing more about what they're doing.
That's right. And we have evidence of that people who do one project are likely to do another project. And it may not be, and this is another area that Karen studies and her team looks at pretty closely. They look at data from SciStarter and other sources, but there's clear evidence people do more than one project. It's not always within the same field. It's sometimes surprising what we find there.
Because they like doing it.
They like
rewarding.
Doing it. It may be convenience. I mean, they have lots of reasons for doing it too. One thing we definitely know from that National Academies report is careful consideration of your design, of the design of your project, can help increase learning outcomes. So understanding the impact of somebody's motivation and identity, the persistence, the feedback they get on the quality of the data that they're submitting. These are things that can be built in to design a good project, and we know that they can maximize learning outcomes and lead to better quality data. So, good advancement for particular areas of research too.
Can we choose one project maybe and talk a little more specifically about the contribution so that we can illuminate what sort of contribution it is? And the one I was thinking about was some of the bird population studies, or even the butterflies, where the observation might be something as simple as, I saw 3 butterflies today, or in the flu near me, it may be, no one near me has a temperature today. And that is valuable if it's in the context of some thought out, structured work.
Each pick a project to talk about.
I think that's a good idea. And I just, obviously, I'm sure most of us can see I've shared the SciStarter screen, and, you can put things in look for the keyword. I like dog, and select a topic. And so this is what a nice, lovely website. a resource for people to go to, and the images you've chosen really represent the broad range of people who might be interested in doing citizen science.
People
It's
who want to do something and don't know where to start, or
don't know where to start.
How to find a
Right.
project.
Well, that
so-
brings it back to the book, which
Yes.
is sort of
Yes.
which
Yes.
is a sister thing to the website, to the SciStarter site in many ways, because both do have that same intention,
Yes.
helping people who maybe have not even heard the term or familiar with that their interests might align with citizen science. But anyway, helping the absolute beginner understand what it's all about and how to get started. Because often that initial hurdle is like the biggest thing. You know, whether you're a teacher and wanting to bring it and get your students involved, or a Girl Scout troop leader, or, you know, a corporate volunteer program that wants to do some volunteering for science, or, you know, or just whoever you might be. I think that's partly how we tried to arrange the book.
Mhm.
Like,
Mhm.
what your motivation might be, how that entry is going to look for you, and what we can do to make it like as smooth as possible.
So I read that Catherine has contributed to several. Choose one, tell us about it so that we know what the data are like, and how they're collected, and how people can contribute, and how it's a real science project. I still think that's the most important.
Yeah. Okay, I'm thinking of two examples. One of them, I use iNaturalist a lot. That's a really popular platform for biodiversity. And one of my favorite observations I made was I saw this. So I used to study spiders, so I have a particular interest in when I see cool spiders. And so I saw this spider, and I was like, this looks really weird. And so I took a picture of it. I knew it was a jumping spider, but it was something I'd never seen before. And so I posted it on iNaturalist, and people started to help me make an identification as to what it was. And so someone identified it, and I looked up that species. And I'm in Nashville, Tennessee, and this species range was only up to like maybe Texas, Louisiana. And so I asked them on iNaturalist, I was like, are you sure? Because this is saying that this is the range of the species. And they're like, no, I'm pretty sure that this is right. And so what your observation is showing is that this range is either expanding or something is going on, because you saw this individual outside of its observed range. And so they were going to, I connected with some people on Twitter, and they kind of got with the people who had written the, species distribution for this particular spider to say like, hey, we found this, somebody found this in Nashville. And so, that again was me just like, oh, this looks kind of neat. It's something that's in the back of my mind when I'm out doing things. And so I contributed that observation, and that ended up being important. Some other observations I make might not be super key right away. Maybe over time, they become a broader thing. Another project that I've done, I think at least twice, is collecting soil samples and sending those in. And that's super easy because they send you the packet, send you the little scoop, they send you everything you need. And then you go and scoop the soil out of your yard, put it in the bag, seal it up, and send it back. And so when I moved, one of the first things I was excited about doing was, okay, I get to make a new soil observation at a new house. And so I ordered my soil kit and got it there so I could send in, the new soil sample from that address. And it's really neat because then you can go on their website and see what they found, to see what type of fungi they're finding in your soil. And so that kind of feedback that Darlene was talking about in terms of, being able to see the value of your contribution, that's really cool. Even if that fungi they find isn't going to be super medically important, they're at least showing me like, hey, this is what we found in your soil. Here's their names. This is what they look like. To me, that's cool. And so those are two that kind of popped into my mind as being ones that, were really kind of those one-time little observations that became important. So yeah, and there's a ton. I'll leave some other projects for Karen and Darlene to talk about.
Not data that they didn't require from you a long-term commitment. It was a one-time thing that's after not years of observations at your house, but observations all around as far as they could reach them. And that gives us important information about what happens in different places, the extent or non-extent of some animal species and things. Karen.
Oh, I am participating in a citizen science project now, run by NASA, which is actually, they gave participants a purple air air quality monitoring device that I attached to my porch and then hooked it up. It's on the internet and it's displaying all the time, real-time readings. So that's what I really like about it in this case, is like, I don't even have to wait for like a sample to get processed. This sensor like is immediately displaying what the air quality is at my house and, you know, all the other people in the area that are participating. Yeah, with the, I mean, it's very, in some ways similar to like high density weather stations or whatnot, right? And so we can start to make forecasts and model things better and just understand how to mediate things in this case a little better. But yeah, but one of the things that I like that Catherine said, I mean, not to go off, you can stop me if you said it's casual.
Whatever.
A tangent, but one thing I like that she said was like maybe that some of her observations might not be meaningful now, or like show something in particular by itself right now, but might be in the future. And I think that's I like to emphasize that too, because like just to have like baseline information on species distributions and on environmental quality, especially in our rapidly changing world, is really important to have. So in some sense, all of those observations you've made are important. We just, it's like you said, we just don't even know yet, but they will be.
Yeah, I think about like phenology and the timing of spring. There's a lot of that, like spring is coming earlier, is coming from things like Nature's Notebook, where people are just like, oh, I found a flower today. And then they're looking and it's March 6th, it's March 2nd. Right. And that's something that at the time, you know, was just part of the observation that they made. And then with that time, that long-term monitoring, it shows a broader trend. And that's a key part of, like we said at the beginning, citizen science is science. That's a lot of how some long-term ecological research goes, is you just keep on making the observations. So
that the science is not in using the biggest instruments and things to make a single observation, but is in how you could look at a collection of observations and look at the patterns and things. And so it is a real contribution, just maybe not the way everyone pictures science being done all the time. Darlene?
Yes, I'm just also texting our developer to see what's going on. I know he's been updating the site. All right. Isn't that fun? Okay. An example I wanted to use is different. It's for medical research, and this is the one that advances research on Alzheimer's. This is called stall catchers. And so the Pietro Michelucci, who's the lead scientist on this from Cornell, he's been helping researchers at Cornell kind of go through lots and lots of data. So this is a case of an abundance of data. And so what the graduate students there do is they spend their days looking at very short video clips showing blood moving through the brain of a mouse that's been infected with Alzheimer's. And they look for when the blood has stalled or when it's flowing. And so this is an example of a platform that was created in part to teach people how to relatively easily identify whether or not blood is flowing or is stalled. And so the very short video clips, and there's a lot of them that need to be analyzed. So people get to look and say, all right, it's stalled or it's flowing. 10 people need to see the same thing in that short video clip for it to be considered credible data and kind of moved into research rate data. The reason they look at that is because the researchers found that if they're able to reduce the number of stalls in the mouse and try some new drugs on them, they've actually shown that they can like reintroduce memory. What's the word I'm looking for? Like memory is restored. So this is incredibly important.
That
word. Are we subjecting you now?
In fact, I'm one of their subjects.
Subject, please, everyone, go to the app and help.
But this is a good example of asking people to use their skills, their people skills, just at looking at things and seeing something that computers are very hard to program to do.
Yeah. So in this case too, we tried something out last year during Citizen Science Day, which was a day last year. It's a month this year in April. And by the way, all of these projects that we're talking about are featured in the book.
Yes.
So you can go into more detail. And in fact, you'll hear a story from Pietro of how he got started and how it got from there to here and some of the outcomes of their work. But we looked for a weekend. We tried for an hour, but it spread over a weekend because of technical issues, not ours at that time, where we had people all over the world engaged in that project. They came into libraries, so socially they were connecting with each other. They were learning about the project. They were onboarded, and then they did this project. It's not the easiest project to do in order to start to count towards the research, because there's a fair amount of data that you need to submit to make it out of their training too. So even with that, in that weekend, the citizen scientists were able to advance as much data analysis as it would have taken those Cornell researchers to do in 9 months. So they did one weekend of work, accelerated like a whole batch of data, done, move on to the next set of data. That makes people feel really good. I also love that project because it crosses generations.
Right.
There are a lot of older people who are working on that project who typically wouldn't get involved in an online gamified project either. So it's really neat to see.
But you highlight too that some projects ask for some training, and the training is interesting and things, but it's training and a commitment. And some, like the one that Catherine talked about, take virtually no training at all. There's something for everyone.
There is.
And it can all be found right here in this book. I need to mention.
Yeah, in the book. And I want to point out one that was mentioned several times that I actually love. I'm a cell biologist. Guess what one I love? Fold It. Fold It is, and they have published papers on this. They have been able to use humans are better at predicting folding patterns than computer programs. And this has been around a while, and it's genius. And he's come up with other ones about RNA folding. And, so I love that one. I've played that. You got to go through some training, though. You can't. So some of these you could just run outside, right, and take a picture. You've got to sort of know where to go, but they're not too difficult. And some, maybe you have to have a gamer's mind. You have to be willing to learn, how the method is done. But that's how you can best contribute to the scientists. Yeah, I'd love to hear what you.
Yeah, I think that training component is so important, and I think as somebody looking to get started in a project, recognizing that, doing those training sessions with stall catchers where you're kind of like, okay, I just want to get to it. I want to get to it. Or even reading the instructions before you do something, like, okay, I go out, I collect the soil, all these things. That's really valuable because again, this is not, this is a scientific data that you're collecting. And so there's a lot of, protocols that a scientist has put in place for particular reasons in order to collect the best data. And so it's important to kind of recognize that and to read those instructions, to take those trainings seriously, but then also not to feel like, if, for example, in stall catchers, that you mess up and you say, oh, I think it's stalled and it's actually not, that you've made a huge mistake. They also build in ways that those types of things are fine, because I might say one thing, Darlene does it, she says something else, Karen says something else, and then we get Joanne and Jeff in there, and finally we start to kind of figure out, in that stall catchers example. So I think, take that training seriously, take those instructions seriously, but also don't take that so to yourself that if you, make a mistake that you've ruined everything.
It's all part of how science works anyway.
It's true. If it's okay, I realized that I forgot to mention that Karen has written another book, right, about citizen science. So here it is on my phone. So we can say Citizen Science, How Ordinary People Are Changing the Face of Discovery. Do you want to tell us a little bit about what that book was about?
Sure. Yeah, thanks. The focus of that book, each chapter is a different discipline. And it tells the story of a major discovery in that discipline that came about from citizen science, really. And just to show all these different fields are advancing in different ways through all these different styles of citizen science that we've been talking about. And I think, well, I don't know, in some ways that helped get us ready for this field guide book of kind of stepping back from that, which goes through a lot of history also and how things have changed over time and whatnot. But to say, okay, what does it mean for someone who's starting right now with a fresh look at all of this? which was something really fun to put together.
That's really cool. Before I ask how you guys came together to do your book, I do want to mention 2 books I can think of right off the top of my head that have been written based on Citizen Science Project. They're not books about, well, they are about citizen science, but Rob Dunn, I think everybody here knows Rob Dunn. Sorry, it's an audiobook on my phone, Never Home Alone. And his book was written based on information about people had to submit samples from all over their house about what lives in every house. And so he was able to, he's still working on this, I believe, but able to then talk about the wildlife in our house that we may or may not even be able to see. But then he even came up with an enjoyable, all of his books are enjoyable, by the way. If you ever want to read enjoyable books, Rob Dunn is one. And then just the other day, I saw in the library, sorry, the shiny cover, The Crowd in the Cosmos, sorry. This is Adventure in the Zooniverse. So they wrote a book about all the information they've gathered and how they've done the project for Zooniverse, Galaxy Zoo. So I thought, oh, that's cool. We got some cool books being written about individual projects that there's so much to write about, they have to put it in an entire book.
There's a few, I think there's a list on SciStarter of books too, like Reinventing Discovery was one of the, I think, sort of earlier books on citizen science without using that name. There's been a few like that. There's a little, I think there's a list, right?
There's a list, and there's an even bigger list now. If I'm afraid to put a link in, because I know Daniel's doing database maintenance. He's our lead person.
Oh, okay.
But we do a lot of work with libraries now, and the librarians have been amazing about creating subject-specific book lists around citizen science. I mean, it turns out there's dozens of books.
Yeah.
So,
and all ages. Yeah. What I look forward to is when the bookstore has a section that's labeled citizen science.
Right. Yeah, I can imagine.
My book, they're like, where was it going to go?
Well, I will say with this book, as Catherine took a picture, it is the first time I've seen a citizen science book in like the general reading area. I think that was in science next to Buzz Aldrin's book. I mean, and pictures from bookstores like, your book is right front and center at Barnes and Noble, or these other things. That's kind of cool. We're getting there.
Yeah.
So that's great. I'm glad to hear that. I am so curious. Okay, how did you 3 come together to make this book? Right? How did that happen? You're all in different places right now. Nashville, North Carolina.
Together for years. We've worked closely together before Catherine moved on to greener pastures. And somebody from Timber Press had approached me about writing this book. And as we had a number of conversations back and forth, I said, what you're describing would be a great book from the SciStarter team. And there's more members than the 3 of us. We were the 3 who kind of signed a contract and said, all right, fine, we're definitely committed to this and we're going to do it. But in reality, there's SciStarter team members who have recommended projects, looked over these. They know the projects inside and out. And so SciStarter is really what keeps SciStarter going, from school programs to library programs to museum programs to the Girl Scouts and all over social media and so forth. So I do want to give a big shout out to that team for the work that they've done on this book too. But in the end, the 3 of us committed to writing it and editing it, and I guess kind of putting our money where our mouth was. And Catherine did an amazing job of just like, as she always does, like making sure that we said we were going to do.
Yeah.
Also, Catherine, everybody pulled their weight in a neat way. I mean, you can kind of hear our voices, different voices throughout the book. But also they had an amazing editor who looked and said, oh, kind of all over the place. Let's really simplify this and bring it down to brass tactics. And I know Karen and I are probably under the same mindset of like, don't we need citations? Like when you write a certain kind of book, and then this a little bit too easy breezy, but it is what works. It's what people like about this book. We've got great reviews. I've done a couple of book talks at bookstores, and it's so really gratifying to hear how well received the book has been.
It's
For
super
actual-
accessible. Like the
Yeah.
editor was great and really helping make every part of it, both like in terms of the language and the layout, like everything, making it super accessible for people.
Yeah, I like the layout, and I like, you know, how
Mhm.
every project, it has the same format. Here's an introduction, location, materials. You know, is there a website? What is the goal? What is the task? What are the outcomes? Why we like this? That was my favorite paragraph to read
Yeah.
in all of them. Why we
Yeah.
like this.
Yeah, and I think the layout that we chose for the projects really matches what you'll see on the SciStarter website. So if you go there and look for more information about whatever project that you're interested in, because some of these projects do change, whether they have a new protocol or something, and so we had to write enough information. But really, when you're ready to dive in, that's where you can visit the website and get all those details. And I agree. I think writing the why we like this was fun, because I think I would kind of sit there and I'd be like, I do like, and like really think about like, why is this the project of all of these, tons and tons of projects that we had to choose from, that we put this one in there. And, I think that was where all of our personal interests really kind of came out in terms of what we were excited about and what we thought other people would be excited about.
And that was one of the harder things, was like, I mean, there's literally thousands of projects.
Mm-hmm.
And it was like, but this book will have some of them.
Yes.
It's tough.
Yeah.
So,
And
there we go. Hi, Darlene.
I was looking at 1%. And now,
Welcome back.
I heard everything.
Things happen.
And I think another fun part of the book that we kind of hit on a little bit, but I think that's where, like, keeping up to date with SciStarter, you'll get more of these opportunities, is kind of those chance projects that just sort of happen, that aren't planned out. So the one I think about and wrote about was the eclipse, because in Nashville, we had a total solar eclipse right through here. And so that opened up this amazing opportunity to collect data on what was happening with the temperature and the clouds during the eclipse. And, that's something that we couldn't have pre-planned out, and so it was like, okay, keep an eye on these awesome opportunities that are going to pop up as you go. And those are really fun and really, great to be a part of.
And that was one part of the book I really liked, because I thought, I never thought, like, if I happened to run across roadkill, that I could use this in a citizen science project. I could just pull something up and document and things like that. So that actually is something I'm going to thank you for, because now I'll keep my eye open. Or if you see a dragonfly swarm and I'm like, because most of you go, "Ooh, cool," and you put it on Twitter or something, right? So I was like pleasantly surprised to see that, because I think, every time I go to SciStarter, for instance, I go, well, what do I want to look at? So I think looking at a book has been really helpful for me to get an idea, even though I know about many of these things.
It'll help you find your way in.
It's a good way in, right?
Yeah.
And
The last couple of decades, I've noticed in science, there seems to be a very valuable move towards openness of data and process, particularly for publicly funded experiments, where people now say, the public paid for these data, we should be allowed to look at them. And it's turned into an interesting thing. Now, is it just my imagination, or is it the case that citizen science seems to come almost synonymous with openness in data, and a lot of these projects have publicly available data so that people can also look at that and see whatever they're interested in looking for? Go ahead, Karen.
I think it's a little bit of a mix, though. But in general, a lot of these larger crowdsourcing data sets, where everyone contributes a little tiny bit, are embracing principles of open data access. And but that's for scientists typically, if it's just raw data. But there's also, what citizen science embraces, this aspect of providing synthesized information back that's in formats that's useful to everybody who contributed, which is another dimension. It's not maybe always spoken about with regard to open science. But then it also brings with it a little bit of tensions with privacy.
not getting spooked.
Oh no, I mean,
that's separate. That's separate, right?
Yeah.
Personal
the
privacy.
volunteers the people who are sharing information
Mhm.
about their privacy, right? So I might share information about a bird and where I saw the bird.
Yeah.
That's also revealing that I was there, right?
Right.
Yeah.
So it's also indirectly information about me. So I'm just saying it's definitely there's embracing principles of open science, but there's also like with revealing an endangered species location if it's a species that might get poached, obvious like things like that. There's areas where there's sensitivities needed. If information might lower property values in an area because it's polluted or something like that, there's still open science principles, but it doesn't always mean everything is open all the time.
Yeah. Darlene, I'm thinking specifically that for a long time, those of us who were working scientists were encouraged, let's say, to find ways to engage with the public. And it seems to me like maybe at last we found crowdsourcing, citizen science, as a sort of win-win for everybody. It does engage, yes, and it gives normal people something to do that helps the scientists. It's not make work. It's engagement for everybody, it seems like.
Yeah, exactly. And both sides learn from each other.
Yeah.
And, in, again, well-designed projects, scientists can learn from members of the public. Some projects allow room for like forums and feedback from the public that may be outside of the specific tasks that they were asked to do. That's awesome.
So has this been contributing in real terms to public engagement with science?
Oh yeah, you can see broader impacts being checked off for some of the grant proposals. This is engagement. I will say that I think that people may be surprised that it doesn't always involve engagement from the scientist or the project leader. Some of the work that we do at SciStarter, in fact, is to be the mediary between the scientists and the volunteers. Sometimes it's hard for us to get feedback back from the scientists who set up the project. There are projects set up there that are designed for the scientists not to necessarily have to engage directly with these. And not always are these projects designed where the scientist goes out into the public and is physically with people, because if they're typically looking for data that they themselves can't access, which means these people tend to be remote to them. But it's absolutely inching closer to this. And, I get super excited about the ways that we might envision people who just didn't have an opportunity to go to college, and it's a lot of people, or many who science was an interest of theirs later in life. That's myself. I don't have a formal science degree. I had no interest in science until I was already working at a science magazine. But then once I got a taste of it, I really wanted to be involved. And so I see how citizen science can be an on-ramp for people. Maybe the people who didn't go to college, we find out ways to help them get accredited. So their contributions start to stack up and matter between maybe college credits or some advancement in the workforce.
Yeah.
All these questions that we're getting at with learning also go hand in hand with skills and competencies that are practiced or acquired as a result of all of these activities that they're doing. So
right. And I saw, yay, Girl Scouts, you can get a badge, right?
And Girl Scouts are early with that. That's right. That badging thing is kind of important. For them, it means something, but there's a whole effort out there with badging and microcredits that actually matter. And as they stack up, it's leading to college credits, and it's leading to industry being able to identify talent to hire based on your skills and your experiences, not just your academic resume there.
I want to express an appreciation, though, for something you said, all of you said when we were first starting, of looking at so many STEM programs that were all about educating young people, which is a valuable thing to do, to reach out and educate young people early about STEM. And when I was thinking 15 or 20 years ago about how to get involved with public engagement and things like that, and I would look at projects, every now and then I throw up my hands and say, what are adults, chopped liver? Because it seemed like every grant program was geared towards ages 5 through 12.
Totally.
And it's like, there are adults, and the adults are interested, and they're an underserved population, and they're a vast resource. And this was obviously before citizen science became such a lovely thing, and I didn't think of it, darn. But it's very nice that this is something that can engage children, and sometimes is designed for that, but really is explicitly a place for adults who are non-scientists but are interested somehow to make a real contribution, and coincidentally to learn at the same time.
Yes, and when we thank you, and that's exactly why SciStarter was started. It was, gosh, there actually are ways for adults to engage, and I didn't realize that. I always thought the battle would be with scientists and kind of validating, like, oh, this could be a real thing. Half the battle is with us, and when we're out at live events and just having to remind people over and over again, they'll hear of SciStarter. We'll tell them about a citizen science project, and they will think, even with that book, they will say, I'm going to make sure that my daughter's science teacher knows about this.
I get that all the time. People introduce me as like, oh, you do science education.
Yeah. It's a hard one to get over. And it's also, I think, important for people to know too, like, nobody's trying to convince you to be a scientist either. We don't expect you to do citizen science and go be a professional. Karen has some real good sections in the book talking about, like, we don't expect kids who practice baseball to be professional sports players, and yet we celebrate what they do there out in the public. And I love those analogies. But I think there's a fallacy even with most of the STEM programs that are out there for kids. This undertone of, you need to learn this so you can be a scientist is really damage. That's exactly why I turned away from all those messages as a kid.
Right.
Probably another show.
It's so true that based on interest that kids express, we have this tendency to be like, oh, that means that's your career track instead of, and we do it with certain things and not others, instead of being like, oh yeah, that could be your interest through life. That's totally just makes you a well-rounded person, but not necessarily the career path you need to go.
Yeah, I totally agree with that. I find myself saying that very often, like, if you love science, if you love the environment, if you, love all this stuff, but you decide to do something else, like, stay with it, whether you do citizen science or whether you, create art pieces that talk about science or you write about science, there's so many other ways to continue to push that and move that forward. And citizen science is one really exciting component of that. So I think all three of us kind of have that same mindset. So we're always pushing that forward. Yeah.
I mean, I don't want to belabor it, but Joanne, you showed Rob Dunn's book earlier. And like, that's one of the things he's actually really, one of the many things he's really great at is like the science of that's in everyday life.
Right.
So it's stuff like, he has like projects with sourdough bread or, just things that are everyday that people don't even think of as science. So they wouldn't ever express like, oh, I have an interest in science. Really, well, you're interested in sourdough and the microbiology that goes into that. And then it's like, oh, I guess actually I am interested now. Oh, that's science. Oh, and that's something I can share information about. That's amazing.
So, I just want to, before we go, I do want to mention, I really like that you actually added on the end, month by month projects that might be good for each month, right? To sort of get people started or thinking, or, it's January and it's freezing, so why not learn to play this video game that helps you fold proteins? Or we might see things. So that was inspired. Does anybody here have a favorite month for citizen science?
Catherine, because Catherine really led the development of that calendar, and she did it twice. She did it first for a PBS TV show called The Crowd in the Cloud. Calendar. So what's your favorite, Catherine?
I know, gosh, I'm trying to think. I think that it's easy, like in the spring and the summer, kind of those go outside types of months. But I think that the projects that we feature more in January, February, that are like thinking like the Smithsonian Transcription Center, where you can be inside and you can be at your computer and you can be doing something, if it's snowing outside. I think that's really fun. And I think that's usually the time when maybe you're more likely to kind of be like, oh, I got nothing to do. I can't go outside on a hike. I can't do the things that I typically do to maybe enjoy science. So here are some other really great ways to do it. So I think that those are really good. And like Darlene mentioned, we had that for the crowd and the cloud, but the SciStarter newsletter, that's a lot how it's set up. So it continues to kind of give you projects based on the time of year, and calendars of events and different things like that, so that you can always find something to, hop into.
Right. And well, since we are closing in on an hour, I was wondering if there's anything else any of you wanted to add before we sign off.
Well,
We forgot to mention, or
sign up for SciStarter. Everything is free to help you navigate through the 3,000 projects in addition to the book. We do have an AI-powered recommendation tool. So it does provide 3 projects that are recommended for you as soon as you hit the site. That way it saves you a little time from having to sift through 3,000 projects. And
Yeah.
do science.
It's true. Anything else, Catherine or Karen?
I don't think so. We covered a lot. So
Yeah, we really did. We really
Excellent.
did. This book is great. It did, like I said, I've gone to SciStarter and I don't even know where to start, except I go, well, biology. I've done BioBlitz. I've done RiverWatch, EcoWatch. These are like actual training programs. You go out, and before apps, before even probably the internet, I was doing those things. But this just makes it so much easier for everybody to get a chance to get an idea of what's going on. You gave a lot of good hints.
Yeah, to kind of dovetail from that, Joanne, I think, we talk a lot about, we tried to find projects that could kind of be done anywhere, so that no matter where you picked up the book, you were able to participate. But look in your local community. A lot of nature centers, a lot of science centers, libraries, will have opportunities. So there are really cool ways to get involved locally as well. And so even if those may not have been featured, they might be on SciStarter. So look in your local community to find other opportunities, especially for those kind of get together and get trained sort of opportunities.
That's true. That's true. Karen, anything from you?
We covered a lot.
I know, you're right. We did.
It's all good. But thank you. Yeah, I'm so glad to talk about citizen science.
Yeah, well, thank you. Thank you. I really enjoyed this book. And
Thanks
actually,
very much.
there's something a little bit that wants to buy a whole bunch and just give them to schools or something, So I think I may be doing something like that in the near future. So
Thank you for this opportunity to spread the gospel of citizen science too. We really appreciate it.
Absolutely. We're so happy to have you, everybody. If you just joined us, we were talking about the book, The Field Guide to Citizen Science, which takes some of the projects from the SciStarter website, and we will include those links in future postings about this video. So everybody can participate in a citizen science project that they find appealing. So thank you, Darlene, Catherine, and Karen for joining us. And of course, Jeff, thank you so much. And we'll see you again next time on Read Science.
Thank you.
Thanks.
Bye.
Bye, everyone.
Bye.